Hey everyone, this video is meant to guide you through the Learning Outcome 9 to 11 Graphs and Key Features assignment. As a cat walks along the railing of a balcony, it knocks a flower pot off the railing. The function h of t equals negative 16 t squared plus 64 gives the height h of the flower pot after t seconds when it falls from a height of 64 feet. Part 8. Complete a table of values. In order to complete the table of values, we need to take the function we were given, h of t equals negative 16 t squared plus 64, and type it here. In my example problem, it's already typed. You may need to type it in some of your problems. The first column, t, represents the time. Given the time options 0 seconds, 1 second, and 2 seconds, we're going to find the corresponding heights. Let's start with 0 seconds. We're going to take the function, replace t with 0. In other words, the height at 0 seconds is equal to negative 16 times 0 to the power of 2 plus 64. This results in the height of 0 is equal to negative 16 times 0 plus 64. Why is this? 0 to the power of 2 is equal to 0. That's why we replace that 0 squared with just a 0. Let's continue to simplify. Negative 16 multiplied by 0 is 0. Therefore, we end up with this 0 here. So if we read the complete equation or function, we now have h of 0 equals 0 plus 64. In other words, the height at 0 seconds is 0 plus 64, which, if we finally simplify the last step, the height at 0 seconds is equal to 64 feet. Now we repeat the process for 1 second and 2 seconds. So for 1 second, we repeat the process, plug in 1, simplify that 1 to the power of 2 as our first step, resulting in 1. The 1 multiplied by the negative 16 is negative 16. And when you take negative 16, add it to 64, that gives you 48. In other words, the height at 1 second is equal to 48 feet. In other words, in 1 second, it's already fallen 16 feet down. Lastly, if we plug in the value 2 for time, the height at 2 seconds is equal to, again, we continue the process of simplifying by starting with the exponent. 2 to the power of 2 is 4. 4 multiplied by the negative 16 is negative 64. And negative 64 plus 64 results in 0. In other words, the height at 2 seconds is equal to 0 feet. Part B, graph the function. You will click on Go to Desmos to open up the Desmos graphing calculator. You will then end up with this page here. I recommend that you click the sign up option or login option if you already have an account, and stay logged in so that any work you do stays saved here. I'm going to start by typing the function we were given. h t, in other words, h parentheses t, is equal to negative 16 t to the power of 2. To get the exponent, we can either use this keyboard, which you would have to expand, and then type this a to the power of 2, which gives us an exponent of 2, or this a to the power of b, which allows you to type any exponent, which again, our exponent will be 2. The keyboard shortcut is Shift 6, which gives you access to what is called the caret symbol above that 6 on your keyboard. We type the 2, and now I would press the forward key on my keyboard, or simply click ahead to get the cursor size back to the normal size. So negative 16 t squared plus 64, where again the 64 represents the original height, where the flower pot started. Now we have our graph. I'm going to minimize this keyboard or keypad And I'm going to start zooming out using the minus. Zoom out, zoom out, zoom out. Now I'm going to drag this graph. Here, we do not need any of the negative values. We're going to adjust our settings, clicking here, graph settings. The x-axis, remember, is the horizontal axis. We want to start at 0. So our minimum value, or our low value here, we delete, will be 0. And when you think back to the number of seconds we used, the highest value of seconds we used was 2. That's when the flower pot hits the ground according to our table calculations. So here I'm just going to round up to 5 so that we include a little bit of extra space past the 2 seconds. So from 0 seconds to 5 seconds. We could add a label here to represent time. And now the y-axis. The y-axis represents the height. So when you think about the height, the lowest possible height is the ground level. So in this case, the ground level would be 0 feet. 0 is our low end value. Our high end value, remember, we started at 64 feet. So I'm just going to go slightly above that, up to 70 feet. Now I'm going to close my settings option. One more piece I would like to include are the points of values that we came up with in our table. If I press return, I have the option to type. In this second box, here I will type parentheses, 0, comma, 64, which represents at 0 seconds, the flower pot is at 64 feet above the ground. I will check off the label in order for it to appear on my graph. I now start typing in the third box. I either press enter or just click down here to be given the option to type. Now, at 1 second, flower pot was at 48 feet. Again, check off the label so that the point appears on your graph. Lastly, at 2 seconds, the flower pot was at 0 feet. Click the label again so that it appears on your graph. You've now created the graph using the Desmos calculator. We now want this graph to appear on our document. What you can do is click Share Graph. When you click the Export Image option, leave the settings as is, medium square for the size and thin for the line thickness. Click Download, copy to clipboard, and then you're ready to come back to your document. When you're back on your document, you go ahead and click in the box for the graph, the function part B, and you paste your graph here. So go to Edit, Paste, or on your keyboard, hold it down Control, press the V button, and this will insert your graph. Part C, find the domain and range. The domain represents the lowest to highest x values. So remember, along our x-axis, we have the time. The range represents the lowest to highest y values. Remember, along the y-axis, we have the height. So the domain in this case is 0 to 2 seconds because the flower pot went from 0 to 2 seconds until it got to the ground level. The range is 0 to 64 feet because, or the lowest point the flower pot ever reached was 0 feet when it hit the ground. The highest the flower pot was ever at was 64 feet above the ground when it was sitting on the rail. Here, we wouldn't start with 64 and then 0, simply because the flower pot was at 64 feet, then drop to 0. For the purpose of writing out the domain and range, we always start with the lowest to highest value. Part D. Find the maximum and describe what it represents. When you go back to your graph, the highest point is the maximum. So think about this highest point, 0.64. And remember, 0 seconds, 64 feet. What was happening at this point in time? The maximum in this case is 64 feet, which represents the flower pot's location before it falls off of the balcony. Now let's move on to part E. Part E. Determine when the graph is increasing, decreasing, or constant. When is this graph increasing? In this specific example, the graph is never increasing. In some cases, you will have a segment of increase. However, here, that response would be never. When is our graph decreasing? Our graph begins to decrease from the moment the flower pot starts falling off the rail. Or our graph, in this case, is decreasing from 0 seconds to 2 seconds. When is our graph constant? In other words, at a flat point. The only time our graph is at a flat point is right at its initial point here, at 0 seconds, the top of the peak. So it's only at that 1 second, which is 0 seconds. We're ready to move on to part F. Part F, how long will it take the flower pot to reach the ground? In this specific problem, we were able to find in our table of values that the height at 2 seconds was 0 feet. In other words, the flower pot hit the ground 0 feet at 2 seconds. We were also able to tell from our graph that at 2 seconds, the flower pot was at 0 feet. In the case that the value here is not a whole number, one way of finding this would be to click on this point where your graph touches the x-axis, again, your horizontal axis, in decimals, and it'll automatically give you this point where it touches the x-axis, which will represent that point where your object either hits the ground, hits the water, gets to your 0 value, okay? So make sure you do that in the upcoming problems. So in this case, how long will it take the flower pot to reach the ground? It will take the flower pot 2 seconds to reach the ground. Let's move on to part G. Part G. Determine the rate of change between 0 and 1 seconds and also between 1 and 2 seconds. Let's use the following formula. Rate equals change in height over change in time. In other words, the change in height divided by the change in time. h2 minus h1 over t2 minus t1. So here, the h2 represents the second height minus h1 being the first height. Remember, the second height was 48 feet, while the first original height was 64 feet. T2 minus T1 represents the second time value minus the first time value, which was 1 second for the second time value and 0 for the first time value. So 48 feet minus 64 feet divided by 1 second minus 0 seconds. That is negative 16 feet per 1 second. As a sentence, the rate of change between 0 and 1 seconds is negative 16 feet per second. So the negative in this case represents that the object is dropping. The rate in this case is downward. Similarly, to find the rate of change between 1 and 2 seconds, we take the second height value of the 2 points we're now referring to. So referring to 1 second, 48 feet, 2 seconds, 0 feet. So the two height values, starting with the second minus the first, would be 0 feet minus 48 feet, which results in negative 48 feet. The second time minus the first time is 2 seconds minus 1 second, which results in 1 second. So as a sentence, the rate of change between 1 and 2 seconds is negative 48 feet per second. Again, the negative simply means the rate is downwards. It's a decrease.